Welcome to the Mr. Beacon podcast. This week we have Silicon Labs on the show. Their senior director from their product marketing organization, Dhiraj joins me. Super knowledgeable person working for this billion-dollar mainstay of the Internet of Things. I'm biased, but I see the silicon chips as being pivotal to what we're doing in IoT. And Silicon Labs has a really comprehensive portfolio of products. They're not tied to just Bluetooth. They have offerings that support all of the major IoT protocols. And so they've seen a lot. Their chips are in an incredibly large number of edge devices. And they have, in the last year, been talking about Ambient IoT, helping to educate the ecosystem about it, and launching Ambient IoT products that can be used to enable devices that subsist on energy that is harvested from the environment, very low cost. So I hope you find this a useful addition to your encyclopedic knowledge of this industry that's changing the world. Check out this conversation with Dhiraj. Dhiraj, it's great to have you, someone who's right at the center of Silicon Labs, on the podcast. Welcome to the Mr. Beacon podcast.
Thanks, Steve, for having me at the podcast here. I'm looking forward to the conversation. I've heard a lot of good things about the podcast. I've heard a lot of podcasts that you've done. So all of it is excellent work. I'm looking forward to it.
I appreciate it. And this podcast is a continuation of the Beacon Technologies book. It's an attempt to kind of make it an evergreen thing. And we try and help people understand the building blocks for IoT, for what we now call Ambient IoT. It wasn't a thing at the time I wrote the book. And the chip vendors are really at the heart of it. Maybe I'm biased because I work for a chip vendor as well. But I feel like, what we do are the essential building blocks, the Lego blocks that everything else gets built out of. And without those core engines, then it just doesn't work. And Silicon Labs, I think it's fair to say, is really focused on Internet of Things and kind of the local area network, as opposed to kind of the cellular modems and all the stuff that the Qualcomms do. So I'm looking forward to really understanding a bit more about what you're doing in Ambient IoT. I've seen a bunch of announcements from you, a lot of products. So I also want to understand more about Silicon Labs. I think people need to understand the neighborhood and who the giants are, and Silicon Labs is very significant. So let's talk about that. And lastly, I just want to pick your brains about what you're seeing in the industry, what's moving, where the growth is, where the opportunities are. So maybe we should just have a brief introduction of Silicon Labs, and then we'll get into the Ambient IoT. For anyone that's not come across Silicon Labs,
Sure.
Who are you? What do you do?
Absolutely. So Silicon Labs, we are focused on wireless solutions for IoT edge devices. Really, right? So we are not really going after really large devices, for example, cell phones, laptops, none of that stuff. It's really focused on the edge devices. We have, in fact, if you really look at Silicon Labs, we have the widest portfolio of all wireless technologies which are used in IoT devices. So name it, and we have it, right? If you look at Wi-Fi, Bluetooth, Zigbee, Z-Wave, Matter, Sidewalk, some of the new ones. Then we have Wi-Sen, which is another one which is there as well, right? So we have a huge, in fact, the widest portfolio, and we always strive to stay on the leading edge of these wireless technologies. We are very active in all of these alliances to see what exactly is required by the end customers and how we as Silicon Labs can help out these end customers to design IoT edge devices with these wireless standards.
Very good. And so Bluetooth 6 has just come out. We just recorded an interview with about channel sounding. Only on the Mr. Beacon podcast would you have a whole episode on channel sounding and Bluetooth 6. Is that something that you're going to be supporting now?
Oh, absolutely. In fact, so Bluetooth, we've always stayed on the leading edge of the Bluetooth technology all along, right? So we started working on Bluetooth several kind of years back, right, and decade plus back, right? So, and we have always stayed on the leading edge of all the Bluetooth standards which have come out, including, in fact, 5.x along with 6.0, which is now channel sounding. So 5.x, which had, of course, AOX, some of those as well. So if you look at the applications of Bluetooth, and you know that well, right, from your other Will IoT job as well, and of course you're looking into that, it has huge number of applications, and they're just growing day by day. So of course, everything which was Bluetooth Classic is moving over to Bluetooth Low Energy, right? So all the audio stuff is moving over there as well. Throughputs are increasing, right? So Bluetooth now supports high throughput. They are even thinking of going up to 8 megabits per second in moving forward. And they're also looking at other bands, not just 2.4 gigahertz. They're looking at 6 gigahertz band as well, right? So all of the things are changing, right? So of course, if you look at it, Bluetooth Classic is really primarily focusing now on audio applications, and everything else seems to be moving on to Bluetooth Low Energy, which eventually will take over audio as well. Say channel sounding, of course, right? So we just announced a channel sounding solution as well, and that's one of our major products, right? Because channel sounding is extremely beneficial when you're trying to do, in fact, ranging. And channel sounding, if you look at it, there are a large number of technologies which can be used for distance, direction, all of that stuff. AOX helps out in direction. Channel sounding helps out in accurate distance measurement. And we have done, in fact, we are the only ones who have a kind of production solution in the market today with channel sounding. And in terms of accuracy, we can provide, most of the cases, it will be sub 30 centimeter kind of accuracy with, in fact, with almost about, I would say, 30 to 40 meter kind of a distance. We can go higher than that as well, but certainly there may be some compromises on the accuracy. So there are a lot of applications, for example, like keyless entry mechanism, door lock kind of applications as well, where you can start using some of these channel sounding solutions. So we are quite bullish on that. And of course, from a power point of view, we have extremely low power consumption. And this is something which is a pillar for Silicon Labs, because power is the basis of all of these battery operated devices, right? So you need to keep going lower and lower and lower and provide higher and higher functionality. That's just the nature of it. And this is where this may be perfect segue to ambient IoT now, right? So when you get into ambient IoT, that's exactly what it is, right? So you really have to make sure that your energy consumption of the system is low enough so that it can be powered by ambient energy sources. That's really what this whole thing is about, right? So, but if you look at it, it's not as simple as that, right? You really have to analyze the whole system, starting off with what is your energy source that you're going to use, which harvester are you going to use, what storage mechanism are you going to use, what PMIC, power management IC, you're going to use. Then eventually, what is the wireless connectivity? What is the processing that you're going to use? Really, optimization has to be done on each one of these stages to be able to create a system which is ambient energy friendly system, if you will. Right. So that's where I think we have put in a lot of effort. We are not into energy harvesting solutions. We don't provide energy harvesting solutions of our own. We are dependent on partners who do that, and some of the partners that we have kind of publicly talked about. Dracula, for example, is one of them. Dracula creates these very low kind of light, dim light cells as well, and which can help out in generating energy.
So this is basically a device that can take the energy from light and feed that into the system that you are providing the components for.
Absolutely. Right. So that's one thing which is there. And then in addition to that, we have a partner, EPs. EPs provides a power management IC, and then we have another partner, Energis, right? So Energis, in fact, we can harvest energy from wireless sources as well, right? So of course, that is the energy harvesting part of it. Then we talked about a little bit about the PMIC part of it as well. Then there is storage, right? There are caps and all which have to be used depending upon the solution, the system that you're trying to do. You need to make sure that you choose appropriate storage devices on the energy side.
And you said caps. Caps meaning capacitors, right?
Yes,
that's where you're generally not charging up a battery. Generally, and it doesn't mean to say you can't, but generally you're harvesting the energy from light, from kinetic.
Yep.
In the case of Energis, maybe from radio waves, and then storing it in a capacitor.
And you can charge the batteries. Again, depends on what kind of energy source that you have. There are things that can be done. So Energis solution does have that capability as well. The question is, do we want to get to that stage, right? So I'll get on to why exactly we don't want to get there, right? And there will be some applications where we may need to do that, right? But now if you look at the last component of it, that's where we are focusing as a company. So if you look at the wireless SoC, there's a huge amount of work which has to be done to make sure that it is energy friendly.
And just SoC, what's that?
It's a system on chip, right? So really what we have is MCU, microcontroller there,
Yes.
along with a wireless solution. Wireless could be a Bluetooth solution. It could be 802.15.4 solution. It could be Wi-Fi solution, what have you, right? So, but huge amount of work has to be done to make sure that this device is energy friendly. And what that really means is, first of all, the boot up time has to be extremely, extremely small. The sleep energy consumption has to be very, very small. Transition from sleep to active state has to be very, very fast. The radio has to consume very less energy. It has to be very efficient. You should be able to transfer the data in a very small amount of time and go back to the lowest energy state. So all of these, if you look at it, significant optimization has to be done at the system on chip level to make sure that we are able to use the energy sources which are coming in, and we are not dependent upon some large battery or large energy sources. So this is where we have put in a huge amount of effort. And ambient IoT, we are just scratching the surface right now. It's just starting, right? So there's a lot of work to be done in that space. But with our low power foundation that we have, and all our devices are low power devices, we are progressing towards making every device an energy friendly, energy harvesting friendly device, if you will.
Yes. So you've long been providing system on chip devices with the radio and the processor that will work with smaller and smaller batteries, coin cell batteries, printed batteries. And so, in a sense, that's a form of ambience because the cost is very low, they're very small, you can go everywhere. But of course, you have to change the batteries eventually, and that's where kind of the infrastructure cost goes up. It's not the capital costs, it's the maintenance costs, and that can be the killer. So I think even though I think you can say a printed battery device could be ambient, it's really getting rid of the battery, I think, makes a better ambient device. It allows you to tag more of the everyday things that are around us.
So just one more thing I would add over there is in terms of, if I really look at it,
Sure.
in terms of battery, as you indicated, it just along that side. Of course, reducing cost is an important part of the battery, but it's also from an environment point of view. Because if you look at it, almost about 15 billion batteries are used annually. It's huge, right? And just imagine the amount of dump that we are creating over there. So it's very important to get rid of that and see how we can transition over as well.
Very good point. Yeah, sustainability and batteries have definitely have challenges when you're looking at recyclability and basically even the warnings you have to put on products. When you have a battery, then you have to put warnings, and that can not be desirable from a merchandising perspective, and it can be a problem with temperature tolerance. We see more applications in cold chain where the temperatures are very low and the batteries will work, but the battery life and the performance goes way, way down. And so I think having ambient IoT to work in food freezers and so forth, there's definitely some benefits there as well. So you've specialized in low power. What is it that distinguishes kind of the pre-ambient IoT low power solution and the sort of products that you're making that are focused on ambient IoT? Is it just more efficiency?
So again, if you really look at it, pre-ambient IoT, you had the luxury of battery and in some cases even line powered kind of devices as well, right? And there is a whole big market for that, and we are not saying that's going away, and that's our bread and butter, and there's a huge number of devices which will continue doing that as well, right? But again, as I indicated, of course, first is reducing the energy consumption of the system is good. But you have to look at every step, and that is what we are doing. Every step in the whole system on chip, right? Where exactly can you optimize the time? Where exactly can you optimize the energy consumption? How fast can you transmit the data? Do you really need all the security level that you're talking about? Because as soon as you add additional security layers, does that really complicate your system? Do you need it in some of these devices? Right. So you have to really have a little bit of a different mindset, a different thought process from a system design point of view. And you also have to keep the sources in mind. What are the sources that you're looking at? How much can they provide you? Right. So, and if a source takes a huge amount of time to charge a capacitor and then boot up a system, that's not a viable solution. So you have to look at all of those as well to figure out if it is a solution that makes sense. So we think, for example, our current solutions from asset tag point of view, right? So as you indicated, cold chain monitoring point of view, those are some real life examples where we can certainly use ambient IoT. There could be electronic shelf labels, for example, right? Where you can use the light energy and make sure the shelf label kind of charges on its own as well. So there are a lot of these applications where we can slowly transition from regular IoT to so-called ambient IoT, depending
Excellent.
upon different energy sources.
So, what are the products that you consider to be in that category? What do you have to sell for people that are building ambient IoT solutions?
If you look at it, we have really launched one product family today, which is, we are calling that as XG22 product, which has Bluetooth capability. It has 802.15.4 in there as well. And there are customers who can do some proprietary wireless 2.4 gigahertz Wi-Fi on wireless also on this one, right? Not Wi-Fi, proprietary 2.4 gigahertz wireless. So this is something that they can do. This is something that we have officially launched today. And we are looking at all other products. And as I indicated, we have large number of products on Bluetooth, Wi-Fi, Zigbee, Z-Wave, Matter, Sidewalk. We are looking at all of these products to see how we can continue optimizing the energy and making them more and more energy friendly and more energy harvesting friendly. Right. So that's something that we're looking at right now. So as I indicated, right, so power has always been the pillar for all the products that Silicon Labs does. So in fact, if you look at the MCUs that we have, in fact, if you look at the wireless technologies that we have, right, everything, power is our fundamental pillar. And then, of course, there are other pillars like security that I just talked about. Security is an important pillar, but in some cases, you may need to change the security level to make it more energy friendly. So we understand how exactly the energy consumption changes with different security levels.
Can you be a bit more specific? Because I totally agree with you. You know, if you're going to have a tag in an item of clothing that costs just some socks or whatever, then you're not going to want a full security stack, and you're probably just not. It's just not going to be practical to have a lot of the key exchange and so forth. So, how do you look at that? Give me a few more specifics about what you've just described.
Again, security is a huge level. So there are different levels of security, and some of our devices, we have PSA level 3 security as well, which is built into the devices, which is driven by ARM, right? So
PSA?
yeah, PSA, exactly.
What is that?
So it could be things like tamper-proofing your device, right? So there are a lot of these little things which they keep on adding to it.
Yeah.
And they're important. Again, when you're talking about an enterprise device, when you're talking about a medical device, when you're talking about a home security kind of a device, there are things which are important. But when you're talking about a tag which is going to do maybe a temperature measurement, or a tag which is going to be for simple locationing purposes, right? These additional things are not required. Do you really need to make it tamper-proof? Do you really need to do all the key exchanges which are required? Okay, and what kind of security algorithms do you want to use? So all of those things, I think you can really think about what is the bare minimum that you need to do. And maybe you can say, I don't want anything on the MCU side. I'm okay with just the wireless security part of it. That's fine. So those are the trade-offs which have to be made. And I would say there is no single right answer to this. It's really dependent upon what your application is. And that's really based on that, customers have to decide what makes sense. So what we have done is, in our energy harvesting friendly device that we have done, we have kind of reduced the security level for the applications that we're going after now. And we have other devices which are extremely high security and they can run off batteries. They may not be able to run off ambient light, for example. No, but then there are other components to this as well, right? So then we have the third pillar that we have now is machine learning, right? So machine learning is an important part as well. Right? Now the question is, can you do something with the accelerator? We have a built-in hardware accelerator. which can expedite which can really process things very fast in some of the cases. Can we leverage some of these accelerators to again further reduce the energy consumption of the system? Right. So that's another thought process that we are kind of going through right now, and see how we can start leveraging these accelerators as well. Uh, then, of course, on the software side, what are the things that you can do to optimize the software itself so that the stack size is minimized? It's bare minimum stack which is required for a particular application. So these are kind of different layers, and you really have to look across every layer. And then finally, you have to think about the protocol. Which protocol is suited for a particular application? Do you want to use Bluetooth low energy? Do you want to use Zigbee? You want to use Z-Wave? You want to use Wi-Fi, right? So Wi-Fi, a lot of people say, okay, Wi-Fi consumes a huge amount of energy. In a lot of cases, I would say it may become energy friendly because it can transmit the same amount of data in a much shorter duration, right?
Yes.
And other devices may take longer. It all again depends on
Yes.
how much data you're trying to transmit. And let's say you're transmitting an image. Wi-Fi may be a much better solution as opposed to BLE also in some of the cases, or Zigbee Z-Wave, right? Because it can transmit, go back to sleep. That way you can reduce the energy consumption of the whole system.
I totally agree with that point. I was just our CTO, Alon Yatskeli, who is really the brains behind what we've done in this space, was pointing out exactly that point to me the other day when he was talking about where do we take the standards in the future. Bluetooth is a great transport for ambient IoT, but how could it be made even better? And what does Wi-Fi have to offer? Because of course there's work building the ambient power functionality into future Wi-Fi devices 802.11bp. So that speed, that ability to, even when you're sending just an asset identifier and maybe a temperature measurement, very short. But if I can do that in half the time, then I'm actually consuming less energy. We kind of think that speed necessarily means I'm consuming huge amounts of power, but in many ways the reverse is true.
Absolutely.
The great thing is we haven't squeezed all the juice out of the lemon. There's more that we can do to make the edge devices more ambient friendly and the end nodes more ambient friendly as well.
Yeah. So now if you look at Wi-Fi, going back to the Wi-Fi point, right? With the new standard of Wi-Fi, that is Wi-Fi 6, a lot of improvements have happened in this, right? So really you can have a lot more devices coexisting in the same environment with less collisions. That way you can really transmit freely, right? Earlier, that was not the case. With Wi-Fi 4, a very less number of devices could coexist, and there was a lot more collision which was happening, which was increasing the energy consumption of the system. Because with collisions, you have to retry. With Wi-Fi 6, there's a significant change that has happened. A lot more devices can coexist. So it has become a little bit more ambient friendly. And now there's a whole different angle to this as well, right? So frequency, which frequency domain should you be operating? Sub-gigahertz, for example. Sub-gigahertz can provide you a longer range, much longer range, right? So the question is, in some of the applications that may make sense to use a sub-gigahertz kind of a solution. It could be a proprietary, it could be a standard-based solution, whatever, what have you. But it may make sense to do that along with necessary energy harvesting solutions as well. So you have to look into that component as well. Protocol, then you're going into the kind of frequency that you're using. So all of those are important components.
Yeah. Are you able to talk a bit more about your relationship with Energous? Because that's a company that we've had on the podcast. We've partnered with them. My own company has partnered with them. Can you talk a bit more about your relationship with them?
Sure, absolutely. So we are always, in fact, partnering with companies like Energous who can provide us the necessary energy harvesting kind of solutions. And Energous is a pretty interesting one because they do have wireless kind of charging capabilities, and that is really what makes them interesting. And there are radio waves all around. If there's something that we can do to use that to charge, and that is where Energous comes in, right? So we have demonstrated solutions with them on our XG22 device. We have demonstrated a solution where we had an Energous solution sitting on the side, and that was providing energy to our XG22 for tag kind of an application. So we have done that, and we have done some similar applications with Dracula, for example. Dracula along with EPs, we have done that as well. So the thing is, we are not dictating the energy sources. Energy sources are coming based on the application. We have to look at what are the ambient energy sources available for a particular application. So we are open to all partners who can help us out. It could be kinetic, it could be light, it could be radio waves, or what have you, right? So we really have to look at all of those energy sources, because depending upon the application, we have to pick, in fact, in our case, the customer has to pick the right energy harvesting solution, which can really provide them the necessary energy for the system.
And who typically are your customers?
So customers, in fact, if you look at Silicon Labs, right? So Silicon Labs, we have two major business units. One is industrial and commercial business unit, and one is home and life business unit. So industrial and commercial business unit, so just as the name kind of indicates there. So industrial is, we are dealing with a lot of asset tag kind of applications, right? So location kind of solutions, they could be sensor kind of solutions there as well. Then we have commercial, we have things like ESL, electronic shelf labels over there as well. Point of sale terminals could be there. Agriculture is part of this as well. So we have a lot of agricultural sensors which are perfect for ambient IoT, if you will, right? So then we have home and life, where home is like, of course, yeah, when you're talking about home, there's whole home automation. There are a lot of things that can be done from an ambient IoT point of view there as well, because there are home sensors, temperature sensors could be ambient IoT based. At present, they are not, but there is a transition that we are seeing, which is going to happen there as well. And there is a life, right, where things like, for example, continuous glucose monitoring systems. Then we have customers who are kind of designing the smart watches for using our solutions as well. So there's a whole broad range, because we have a wide portfolio of wireless technologies. And if you look at it, these wireless technologies are used across all of these different applications. But not all of them are battery operated. A lot of them are. And a lot of them may not be energy harvesting friendly either. But wherever we can find a space to get into energy harvesting, we are looking into those solutions.
Yeah, I think it's really exciting seeing new classes of products that are going online, and I tend to talk about the food, the medicine, the clothing, but also the parts of products. So if we look at houses, there's all sorts of opportunities to connect more and more of the components of the house, and I think of like just double glazing, for example. Double glazing, it has a finite life. The life is quite long, so having a battery-powered sensor in your double glazing probably doesn't make sense, but there's all sorts of potential sources of energy that you could have if you embedded connectivity in double glazing. And this is really useful. We have the phenomenon of water leaking into the double glazing. Your glazing gets misted up, and then what happens when you want to repair or you want replacement? If you bought your double glazing 10 years ago, you may not even remember where you got it from. The documentation, the manual, the reorder, the warranty, all of that may be missing. But if you've got identity and a digital product passport that's associated with the double glazing, then that can be really helpful for you as a consumer. And if I make the double glazing, this ability to get the replacement business is just like one example of where I think ambient IoT will spread from some of the applications that we're seeing today to things in the future.
Absolutely, right. So temperature sensors at the home, you have sensors scattered all over, right? So you can have security sensors. That may be another one that you can start looking into as well. There's a whole wireless sensing which is coming up as well, right? So that those applications. And of course, there are other applications. We are pretty big in metering, for example, electric meters, water meters, garage door openers. So those are some other applications that we are big into, right? Some of those applications may not be as much, but certainly I would say some of these other applications we can certainly transition into ambient IoT kind of solutions.
Very good. You mentioned Sidewalk earlier on in our conversation. I'm interested in coming back to that. This is maybe. Can you explain what Sidewalk is? I've been wanting to get someone from Amazon on the show to talk about it, and one day it's going to happen. But it seems like a very long road. So if you can just explain what Sidewalk is and what you're doing there.
So in fact, yeah, of course, Amazon Sidewalk, that's a great technology for connecting neighborhood in reality, right? That's what we're talking about here. And we are a very close partner of Amazon. We have developed multiple solutions with them. Just as kind of the name indicates, it's a pretty nice name. I like it because it's a sidewalk. What we are doing is really connecting neighborhood houses together. So you can for example, share a small amount of your bandwidth. So it's typically, I think it's about 500 megabytes per month is what you share. Okay. And then you can, for example, if your pet or your kids are playing in the neighborhood, through your neighborhood network, you should be able to figure out exactly where they are. So it's really kind of creating a neighborhood network based on existing solutions right now. For example, everyone has Alexa at home. Alexa is Amazon Sidewalk enabled, right? So now the question is, what you can do is you can create devices which can connect to Alexa, which eventually connects to the cloud, of course. And if somebody is kind of walking in the neighborhood, right, your kid or a pet, using your neighborhood network, you should be able to figure out where exactly the kid is, right? So that's a pretty interesting application. So that's what they're trying to do. It's in early stages right now of deployment, I would say. And there are some challenges in some other geographies as well. The technology is very promising. It's leveraging from a wireless protocol point of view, it's leveraging what is already existing, right? So, and that's something that they're doing. And the good thing about Americas, at least North America, the proliferation of Alexa is just huge in the market. And using that, you can really start creating this network as well.
Yeah, so I think there's an argument that says that Sidewalk has a role in ambience. If ambience is connecting every single thing, then the range is really great.
Yeah.
There's a strategy for getting you from the local area to the wide area, because all of your Ring cameras and doorbells and the Amazon Echo devices, they're all connected. So I think it is really promising. And the coverage maps that I've seen are pretty impressive. The level of, if this was a wireless carrier, they would be proud to have some of the coverage they have, especially in the metropolitan areas. So.
Exactly. And the good thing is you're not creating anything new. Of course, in some cases where the coverage is less, they have some specific devices, like an access point kind of a device, which they have. But overall, in general, it's pretty good coverage. And then sensors, for example, you can even put sensors in your, for example, yards and all, and those sensors can be connected to Sidewalk and you can figure out what's happening. So in reality, for example, humidity sensors, which are on the yard, they can be on the Sidewalk network as well. So extremely good use cases. We are very closely engaged with the Amazon team to see how exactly kind of they push it out. We do have a large number of solutions which do support Amazon Sidewalk today as well.
If I wanted to start up a company, I get religion, I want to do Sidewalk, so I buy my system on chips from you, but I need to do a deal with Amazon, presumably, to build that dog tracker or whatever the thing is that I'm building.
So again, at the end of the day, the thing is, Amazon is trying to enable a lot of device makers, so you may not have to directly deal with Amazon so long as you're following the specific protocols. I think so. That's something which is there. So that's the reason companies like us, right? So we have all of those necessary components to make a device which is Amazon Sidewalk enabled, if you will.
Very good. Well, we've covered a lot. I'm just trying to think if there's anything else that you want to cover. Hopefully people have got a sense of Silicon Labs' diversity of portfolio and market presence. Anything that you want to add in this section of the show?
Yeah, so in fact, if I really look at it, of course, IoT has come a long way, right? So I started, because I'm sure you also started looking at IoT when it was called M2M, M2M to IoT to Ambient IoT. There's a lot of progress that keeps happening here, right? So one thing which we are seeing certainly is machine learning. I did briefly allude to that earlier. So machine learning is an important component of IoT. And with accelerators, this is one area that as a company we are focusing on, because we think that's important for all edge devices. A lot more processing is going to happen on the edge. So we started off with, of course, low power, all the wireless connectivity, we have security, we have the software. Now the next major pillar is machine learning. And machine learning, first is we start with standard IoT, then we optimize it further to get into ambient IoT. But that's an important thing which I think is going to drive the industry forward from an IoT point of view as well as ambient IoT point of view as well. So that's an important one which I think I'm not sure whether you've done anything on machine learning, but that's one area that certainly as a company we are focusing on. And machine learning on the edge is a different problem, of course, right? It's a very different problem. So you have, for example, if you want to do data analysis, if you want to do, for example, some audio or voice analysis, some image analysis, some video analysis, everything needs different kind of capabilities. So on an edge side, certainly the limited resources are there, and you may not have an option to, of course, connect to the cloud. So there are interesting techniques which have to be used to make that happen. So that's an area where we think it's going to grow as well.
I couldn't agree with you more. I absolutely agree. We actually had the head of tinyml.org on the show. So if you want to go and anyone wants to check that out, that's really an organization that's promoting moving more and more of the algorithms that in the past may have run centrally on the cloud onto the edge, where there's a lot lower environmental impact and all sorts of other benefits. So we go into that. But I think one other thing I just want to add to support what you've said is that I think it's important that we think about ambient IoT as like the extended nervous system for artificial intelligence. It's all very well having this incredibly intelligent brain, but if it's kept in a jar somewhere and it's not really connected with the real world, then it's hard to really unlock the benefit of both the ambient IoT network and the intelligence, the incredible levels of intelligence. But if we bring them together and we think about ambient IoT as feeding the sensing signals, the events into that central intelligence, and then we think about distributing and taking executive decisions and then monitoring what's happening, then there's I think it's a pretty good metaphor, the extended nervous system for AI. And just like the extended nervous system, all of your intelligence is not in your brain. It's actually kind of pushed down through the spinal column and so forth. And so I think...
In fact, that you bring up a very good point, because that's exactly we just have, I don't know whether you're familiar, we have Silicon Labs, we have our own conference called WorksWith. And we just had our WorksWith Summit in Austin, then we had another summit in San Jose, then we have an upcoming summit in October in Hyderabad, and then one in Shanghai. And there, in fact, we had a keynote with NVIDIA. And that's exactly what we talked about. So from Silicon Labs' point of view, what we are doing is we are providing, in fact, wireless solutions for creating these IoT edge devices. These IoT edge devices, a lot of those are ambient IoT edge devices, will feed into a system which can do a lot more AI processing, right? And it is getting all the data which is required to make that happen, right? So it's an interesting combination. So we are feeding into that system, as you just indicated. So we have all of these sensors or edge devices feeding into a central system which can do a lot more processing and figure out what to do with that whole data, right? So we are enabling that. So this was a pretty interesting, if you get a chance, in fact, take a look at that. It's a combination of a keynote from Silicon Labs and NVIDIA combined as well.
I will check that out. That's fascinating. And what's interesting about it is you have NVIDIA, quintessential chip company, working with Silicon Labs, who's a chip technology, and you see complementary aspects of where those companies fit in at a system level. And I would have invited you. My day job is at Wiliot, and we interview people that have competitive products all the time, because I think it's all about growing the size of the pizza, not arguing which slice is which. But I would say, what Wiliot does is complementary to what Silicon Labs does, kind of with the very tip of the fingertips of that central nervous system. And you have the hands and the arms, and NVIDIA has the brain, and silicon is really the foundation for that complete ecosystem. So.
And we also have an embedded world in Austin coming up next week. It's the first time it's happening in US. So where we have some nice, in fact, we are CEO Matt, as well as our CTO Daniel, they're giving a keynote as well there. So if you get a chance, just take a look at that as well. So we're going to talk about some of these as well.
Very good. Hopefully people will be able to see that online and catch what happened. I think this episode will probably go out just after there, but no doubt these sessions will be accessible for people. So Dhiraj, were you able to choose 3 songs that have meaning for you?
Oh, yeah, absolutely. In fact, just from a music point of view, I listen to more Hindi music that English music. But certainly, I would say 80% plus time is Hindi, but I do listen to a lot of English songs as well.
Okay, well, you can choose Hindi music. We're not. We've definitely had people that have, but it's whatever you decided is fine.
No, no, no. I've chosen some English music which people can relate to that as well. So I do listen to a lot of songs there, but not as much as the Hindi side of things, right?
All right.
So a few things which I picked. In fact, I was just thinking about it, what from a family point of view and really from my past point of view as well, what makes sense. So the first thing which came to mind was really when I talk to my kids and when they are running into some problems, they always say, "What doesn't kill you makes you stronger."
Mm.
Right. So this is something, even though the song, if you really look at it, is more related to breakup and all, but in reality, it can be translated to anything in life, right? So anything that if you are going through a tough time, it's fine. It's going to pass and it's going to make you stronger. It's going to make you a fighter. So this is a song by Kelly Clarkson, right? Who is a Texan born, right? And I'm also in Austin. So it kind of, it works well there as well. Yeah. Yeah.
Very good. Very good.
Uh-huh.
Nice choice.
So this is an interesting one. The second one, which I kind of relate to because I grew up in India, moved over to US some time back, but is the song, of course, the guy is from UK, Phil Collins, Another Day in Paradise.
Ah,
It's a very popular one, of course, and the lyrics are just beautiful over there. And it's an emotional song, right? So certainly, but it's something that I can relate to. Growing up, I had seen a lot of these cases. So it was, I could relate to that song.
yeah. So you're in Texas now. You've spent time in the Bay Area. It looks like.
Oh,
as
yeah,
well.
absolutely. I spent a lot of time in the Bay Area. I spent almost about 20 years in the Bay Area. Then we got acquired by Silicon Labs. So I moved over to
Yeah.
Austin after we got acquired.
And so my transition from having grown up in England and then growing up or being an adult, professional part of my life here, those experiences are very important to me, or just sort of significant. What was it like for you? How old were you when you relocated from India to America?
I was 21. So in fact, immediately after my bachelor's, I came over to the Bay Area, spent almost about 20 years over there. In fact, I even moved back to India. So from Bay Area, I moved back to India for about 10 years. And then I relocated back to Austin after we got acquired. So it was a pretty good experience overall, right? So Bay Area was growing at the time. It is still growing, of course, right? A lot of things keep changing all the time in the Bay Area. So transition was pretty smooth over there. No concerns, of course, right? So I liked all the kind of work culture over there. I did my own startup as well over there, which is the standard culture, of course, in the Bay Area, right? So then
would it have been harder to do that in India? I mean, I don't know what the startup scene is in India.
It has improved significantly, but at that time it was not as big. But now it is huge in India. It's growing significantly right now. Absolutely.
Really interesting.
Right. So and being in Austin also, it's a kind of good experience. It's a change, certainly from Bay Area, India to Austin. I love the city as well. Absolutely.
Yeah. I every time I get a new stereo component, I always play Phil Collins just to test out the bass.
yeah, it's a good song, and he has excellent songs, right? So this is something which I love as well.
Very good.
The third one which I chose was this was also an interesting one, and this is a movie which I watched a large number of times. I'm sure you have as well. The Sound of Music, right? So the song is my favorite things, right? Raindrops and Roses and Whiskers and Kittens. So this is I don't know who originally sang the song, but because it was a play first, and then after that it was converted into a movie. In the movie, I believe Julie Andrews is the one who sang that song, right? So, but it's a beautiful song. Good thing. It's kind of, you need to appreciate little things in life, right? That's really where it is. And those are the things that make you happy.
That is very wise and makes me appreciate the song even more. And thank you so much, Dhiraj, for choosing excellent songs with excellent thoughts behind them. And thank you very much for coming on our podcast.
And thanks a lot, Steve. It was a great conversation. So it's good to see that, in fact, your day job as well as, in fact, this podcast, you're focusing on some of the in fact, some of the technologies which are going to take this whole IoT and machine learning kind of forward as well. Right. So thanks a lot for having me here. And it was great to talk to you. Thank you.
Thanks for watching this episode of the Mr. Beacon Ambient IoT podcast here on YouTube. You can listen to this episode on iTunes, Spotify, or wherever you get your podcasts. If you enjoyed it, please like and share this video. And be sure to subscribe for more videos. For more information about Wiliot, Ambient IoT, and IoT Pixels, head over to wiliot.com.